Welcome to Study Physics. In this video we will be solving problems of chapter 31 and today's problem is 36. So what is asked in 36 is two capacitor of capacitance 20 picofarad and 50 picofarad are connected in series with a 6-volt battery. A part is find the potential difference across each capacitor and B part is energy stored in each capacitor. So for the first part, what is required is potential difference developed across each of the capacitors. So what we have to decide is consider that the potential across this capacitor is V1. And by that time the potential across this capacitor will be like 6 minus of V1, or we can consider it like V2, and after that V1 plus V2 is equals to 6. We can go like that also. So how to decide this V1, and once the V1 is decided we can evaluate the value of 6 minus of V1. So what we observe here is these two capacitors are connected in series. So if the connection is series, by that time the charge or the current in that connection will be common, means equal. So what we can say here is Q1 will be definitely equals to Q2, and we can consider it like Q. So what we can say here is the charge flow through this branch will be equals to Q. So if the charge flow with this branch is equals to Q, by that time what we can say here is, since Q is equals to C into V, so Q value will be like, so this one is the C, so it will be 20 into 10 to the power minus of 12, and V1 value is there, so we can consider it like V1. And similarly we can go from this capacitor, that is Q value will be equals to 6 minus of V, so V1 into 50 picofarad is there, so it will be 50 into 10 to the power minus of 12. So what we can say here is equation 1 and equation 2 will be same, so we can write 20 into 10 to the power minus 12 into V1, that value will be equals to 6 minus of V1 into 50 into 10 to the power minus of 12. So this value and this value will be cancelled, and V1 20 V1 will be equals to 300 minus of 50 V1. So it will be like 70 V1 will be equals to 300. So what we can say here is V1 value will be 300 divided by 70. So it will be like 4, 28 and 20. So 2 and approx 8 something will come. So let us find out the third figure, and after that we will direct. So yes, it is 4 only. So by this way we have decided V1 value, that is 4.28. so now we can very easily evaluate the value of 6 minus of V1. So by that time it will be 6 minus of 4.28 value. So this will be the potential difference across the second capacitor. So this value will be like 1.72 volt. So what we can say here, if we consider this voltage as V2 only, so what we can say is the potential differences will be like 4.28 for the first capacitor and 1.72 for the second capacitor. So what is the first capacitor is 20 picofarad and second will be 50 picofarad. So across 20 picofarad the potential difference will be 4.28, and across 50 picofarad potential difference will be 1.72. So this will be the potential differences across each of the capacitors. So this was our first part. In the second part or the B part, what is asked is the energy stored in each capacitor. So we have to evaluate the energy across each of the capacitor. So how to decide the energy across each capacitor will be like we can do half C V square, or we can do Q square by 2C. So we can see very easily that we have the value of capacitor, we have the value of potential. So if we go for this way, then we have to evaluate the value of Q also, but we have all the data from the first part, so we will go through this part. Okay, so it will be like half, and for the 20 picofarad it will be like 20 into 10 to the power minus of 12 into V square value. So V square value is 4.28. So this will be the charge across the first capacitor. So I will later evaluate with the help of calculator and write it directly. So similarly we can evaluate the value of second capacitor, energy across second capacitor, and that will be 1 by 2 into 50 into 10 to the power minus of 12 into the potential difference across that capacitor is 1.72 volts. So I will square that, and now I will evaluate these two values, and after that I will directly write it here. So the value calculated here is exactly equal to our answer, and that is 184 picojoule for the first part, and for the second it is 73.5 picojoule. So in this way we have evaluated the value of energy across each of the capacitor. So across the first capacitor it will be like 184 picojoule, and across the second capacitor it will be like 73.5 picojoule. So in this way we completed